today our lesson is on systems of equations. If you have not already printed the video guide, go ahead and pause the video, print the video guide, and come back because we'll be doing examples together from that sheet. Now, you'll notice that we are doing substitution again. There is another lesson on substitution. If you haven't already seen that video, I would go back, watch that video first, and then come to the second substitution video. Remember from our previous lesson that substitution just means that we are taking something out and replacing it with something else, okay? It does not make sense to substitute for something that's still in the problem. So you have to make sure that you are substituting for one of the letters. Now, if we take a look here, we have y equals 4x minus 11 and negative 6x plus 10y equals 26. We're trying to solve this system. We have two variables, which means we need to have two answers, an x and a y. To solve this, we are using substitution, but the way that this is different from our previous lesson is that only one of our equations is solved for y. The second one in this case is not. All right, but that's okay, we can still use substitution. You only have to have one equation solved for y. So our first one is solved for y, which is telling us what y is equal to. All of that, the 4x minus 11. So we're going to take that and plug that in for y in the second equation. Now the way this is going to look different, again from our last lesson, is that y is now in the middle of the equation, not just at the beginning like it was before. But the rules still apply. So what happens is everything about this second equation is going to stay the same. The only thing that changes is the y. So my negative 6x stays a negative 6x. My plus 10 stays a plus 10. Now, here's where it changes. That y is going to be taken out of the equation completely, no y left in the equation, and instead of y, I am going to put 4x minus 11 in parentheses. The equals 26, again, that stays the same. The only thing I took out of the equation, the second equation here, was the y, and I replaced it with what y was equal to in the first equation. So now, from this point, I can solve this equation for x because that's the only letter that's there. So I draw my line through the equal sign. I need to get rid of the parentheses first, so I need to do the distributive property, which means I multiply by 10. My negative 6x stays the same. 10 times 4x is positive 40x, and 10 times negative 11 is negative 110, equals 26. From there, I can combine like terms. I have two x's on this side. Can go ahead and put those together. Negative 6 plus 40 is positive 34x. Remember, if the signs are different, you just subtract the two, keep the sign of the bigger number. The minus 110 just comes down, as does the 26. Only thing I changed was combining those x's together. Now I need to get my numbers on the right-hand side of the equal sign. So cancel out the minus 110. So I'm going to add 110 to both sides. They cancel. I get 34x equals 26 plus 110 is 136. Last step, we need to divide. All right, so 34x, that's multiplication. Opposite is division, so we are going to divide by 34. So the 34's cancel, and I get x equals 4. Positive 4. Now, that's part of my answer. Remember, we need two answers. I need an x and I need a y. Now, in this case, I would always use the equation that is solved for y to find y because it's just going to be easier to work with. It is not wrong to use the equation that's not solved. It'll just be an extra step or two to find the answer, but you're still going to get the same answer. So it's really up to you whichever one you'd rather use. I'm going to use the first one because when it's solved for y, I think it's easier, so I like easier. So this first one, we have y equals 4, but instead of x, we are now going to substitute the x with 4. So I'll put 4 in parentheses for x. The minus 11 stays the same. So now, to solve this, I need to do my multiplication first. So y equals 4 times 4 gives me 16 minus 11, and 16 minus 11 is 5. So my answer, the x comes first, 4, comma, the y is 5. So that comes second. Remember, this is just another way of finding where these two lines intersect on a graph. Okay, so these two lines would intersect at 4, 5. It's just a simpler way of doing it, because if we tried to graph this, we would have to solve this for y and then plot all the points, and the numbers are kind of bigger, and so that would it would take a lot more time and not be quite as accurate. So this is an accurate way of finding that answer. So number 1, our solution is 4, 5. For problem number 2, our equations are negative 4x plus 7y equals negative 25, and y equals 8x minus 11. This is a very similar problem. The only difference is the first equation is not solved for y. Okay, the second equation though is. So it's going to look a little bit different, but it still works the same way. We still need to go to the equation where you have y by itself. Always start with the equation that has y by itself. So in this case, it's the second equation. That's okay. So go to where y is by itself, or y is solved for, and box in what it is equal to, the 8x minus 11. Okay, so 8x minus 11 will go in for y this time in the first equation. So that goes in right here. Okay, so the negative 4x stays the same. The plus 7 stays the same. The part that changes is that y. I'm going to take out the y, and in parentheses, I'm going to put 8x minus 11 in its place. After the y, everything stays the same. The equal sign just comes down, so does the negative 25. So the only part I changed here is the y. Take out y, put what it's equal to in its place. And then I solve for x. So I need to get rid of this parentheses. So I do the distributive property. Multiply by that 7. Negative 4x stays the same. 7 times 8x is positive 56x. And 7 times minus 11 is minus 77. The minus 25 stays the same. Okay, from here I can combine like terms. Negative 4x and positive 56. The signs are different, so I subtract. Keep the sign of the bigger number, so I get positive 52x. The minus 77 just comes down, and so does the negative 25. Okay, at this point I need to get my numbers on the right side of the equal sign. So opposite of minus 77 would be to add 77. I need to cancel it from the left and then move it over to the right. So these cancel. 52x equals negative 25 plus 77. The signs are different, so we actually subtract. Keep the sign of the bigger number, so it's 52. And then my last step is to divide. I have to divide both sides by 52. Always divide by the number in front of x. So they cancel, and I get x equals 52 divided by 52 is 1. That's part of our answer. We still need the y part. So always use the one that's already solved for y. It really is so much simpler. You're not going to get the wrong answer with the other equation. It's just going to take you a little bit longer. So I'm going to go ahead and use the second equation this time because it's solved for y. So I have y equals 8, but instead of x, put 1 in parentheses, minus 11. So y equals 8 times 1, do the multiplication, we get 8, bring down the minus 11. So 8 minus 11, I can change that to adding the opposite, 8 plus negative 11. The signs are different, so I subtract. and I keep the sign of the bigger number, so it's going to be negative 3. So my solution for number 2 is 1 comma negative 3. Always put that x term first and then y. For problem number 3, our equations are negative x minus y equals 0 and y equals 3x minus 20. Again, this problem, the y equals equation is second. That's okay. We always start with that one, whether or not it's first or second, doesn't matter. So always go to where y is at the beginning, where y is by itself. So we take y equals and we box in everything that it's equal to, the 3x minus 20. That will go in for y in the first equation, okay? So we're taking out that y from the first equation, we're replacing it with 3x minus 20. Now, I'm going to rewrite this and take out y. So negative x, I'm going to put negative 1x. Remember, every letter has a 1 in front of it if the number's missing. So I'm going to put that 1 just so I don't forget. So after that, I put minus. There is a 1 in front of this y as well. They did not write it, but I'm going to. So minus 1, and then in parentheses, I put 3x minus 20. And then the equal sign and 0. So the only thing I changed about this equation was the y. Everything else, those ones were technically there before. All right, I just wrote them in. So everything else I did keep the same. The only thing I changed was that y. So to solve this equation for x, I need to start with the distributive property. So I need to multiply by negative 1. So I have negative 1x. Negative 1 times 3x is negative 3x. And negative 1 times negative 20 is positive 20. And that equals 0. So once I've done the distributive property, I have some like terms here that I can go ahead and combine. I have a negative 1x and a negative 3x. The signs are the same, so I actually add these two together. So I'm going to get 4x, and I'm going to keep the sign of the bigger number, so it's negative 4x. The plus 20 just comes down. So does the equals 0. Okay, from that point, I need to go ahead and cancel out my number so that it's over on the other side, so that way all I have is x on the left-hand side. So I'm going to subtract 20, do the opposite, because that's going to get these to cancel. Positive 20 and negative 20 are 0, so those cancel out. My minus 4x just comes down, negative 4x, and 0 minus 20 is just negative 20. And my last step is to divide. I need to cancel out a negative 4x, or a negative 4 that's being multiplied by x. So the opposite would be to divide by negative 4 on both sides. So they cancel, and we get x equals negative 20 divided by negative 4 is positive 5. So x equals 5 is part of our answer. To find the other part, again, I would go back to the equation that solved for y. That's the one I'm going to use. So everything about this equation will stay the same, except for this time, I'm going to substitute in for x. So I have y equals 3, but instead of x, I'm going to put 5. And then the minus 20 also stays the same. So our first step will be to do that multiplication. So 3 times 5 gives me 15. The minus 20 just comes down. And 15 minus 20. I can change that to adding the opposite. 15 plus negative 20, the signs are different, so I will subtract them. I'll get 5, but it will be negative 5 because the 20 is larger, so you keep the sign of the bigger number. So my answer for number 3 is going to be 5 comma negative 5. Again, that x comes first and then the y. At this point, go ahead and pause the video, work out problem number 4, and then come back and check your answer with my work. For problem number 4, our first equation is y equals negative 2x plus 11, And the second is 3x plus 2y equals 21. So for this one, our first equation was the one that was solved for y. So I boxed in the negative 2x plus 11, and I put that in for y in the second equation. I kept everything else the same. So 3x plus 2, in parentheses, I put negative 2x plus 11, and then equals 21. So first, do the distributive property. I got negative 4x plus 22. After that, I combine like terms. 3 and negative 4, when I combine those, I get negative 1x, and then the plus 22 equals 21. I subtracted 22 from both sides, so I got negative 1x equals negative 1, and divided both sides by negative 1. I got x equals positive 1, which is part of our solution, but the other part is the y. So to find y, I use the first equation, again, because that's the one that y is solved for. That's the one where y is by itself. So in this case, I took out the x and substituted 1 in its place. So I got y equals negative 2, but instead of x, I put 1, and then plus 11. Everything stayed the same except for the x. So I did my multiplication. Negative 2 times 1 is just negative 2. And then I did my addition. Negative 2 plus 11 is positive 9. So the answer that I got for number 4 is 1, 9. And that's the end of our lesson on systems of equations. And this is our substitution lesson number 2.